an increase of 10 in the x direction must correspond to an increase in the y direction of half of 10, which would be 5 units in the y direction. Welcome back. So last time we were looking at the equation of a straight line and how the value of the constant c affects a straight line. So let's take a quick look at what we looked at last time, just as a recap. So we'll select some different values for c. We can see that when the c value is set to 0, the line passes straight through 0 on the y-axis. Now, changing the c value to -6, we can see that the y-intercept is -6. Okay, so changing this to -6 has the effect of shifting the line down by 6 units. So let's cycle through a few different values just so you can see what's happening to the line as we change the value of c in the equation. -4, -2, 0, +2, and +5. Therefore, the c value corresponds to the y-intercept. Now, we're going to see how the m value, or the coefficient of x, affects some line that is graphed. Now, let's set the value of m to 1. Now, we'll use a fixed value of 0 for c, because for these examples, we'll just be looking at how m affects the line. So just to keep it consistent for c, we'll just choose 0. That means all our lines are going to be passing through the origin because the y-intercept will be 0 if c is set to 0. Okay, so we're just concentrating on the value of m. So setting m to be equal to 1, we get a line that looks like this. Now, how does the number 1 correspond to this line? Well, let's just change the values of m and see how the line changes. So changing the value of m now 2, we can see that the line is now steeper. So let's try a value of 5. So the line is even steeper than before. And changing the value now to 1/2. So we can see that gradient of the line is changing depending on the value of m. Okay, now let's see what it means for a line to have a gradient of 1/2. What does that actually mean? Well, the gradient of a line, by definition, is the amount the line increases in the y direction for each increase in the x direction. Okay, now let's have a look at what that looks like on the line. So for this line, let's look at what happens when we increase by 5 in the x. We can see that the increase in the y is 2.5. Okay, so that means that the vertical increase from left to right is half of that of the horizontal increase. Okay, so I'll repeat that again. The vertical increase as we move from left to right is half of that of the horizontal increase. Now let's see what that looks like if we change the m value to, say, 2. Now this time an increase of 5 in the horizontal direction, or the x direction, corresponds to an increase of 10 in the y direction. Okay, so the m value of 2 means that the increase in the vertical direction is twice that of the horizontal. Okay, now I'm just using an increase of 5 as an example, just to clearly show the ratio between the vertical increase and the horizontal increase. But we could just as well use a horizontal increase of 2 and a vertical increase of 4. Okay, so it doesn't matter what horizontal increase we choose, whatever that horizontal increase is, the corresponding vertical increase will be double or twice as much if the gradient is 2. Now let's change the gradient to another value and see how that affects this line here. So changing m to be equal to 5. Now this means that the increase in the y direction will be 5 times as much as the increase in the x direction. Okay, so let's choose the increase in x to be 2, and let's have a look at what's happening to the corresponding increase in the y direction. So an increase of 2 in the x direction should correspond to an increase of 5 times 2 in the y direction, which will be 10. And we can see here an increase of 2 corresponds to an increase of 10 in the y direction. Now let's have a look at what happens when we change the m value to a fractional value. So for example, if m is equal to a half, well, this means that the vertical increase is half of the horizontal increase. Okay, so this time for an m value that is less than 1, the line increases more in the horizontal direction than it does in the vertical direction. An m value greater than 1 means that the line is increasing more in the vertical direction than the horizontal direction. Okay, now when these are equal, we have an angle of 45 degrees. Okay, so that means a gradient of 1 means that the vertical increase is equal to the horizontal increase because the ratio between the two is 1. So this time the ratio between the two is a half, meaning that the vertical increase is half of the horizontal increase. So an increase of 10 in the x direction must correspond to an increase in the y direction of half of 10, which would be 5 units in the y direction. And just as before, we can choose any value for our x increase, and we'll always get a corresponding y increase of half of this value. So let's take a look at an x increase of, say, 6. So an increase of 6 in the x direction corresponds to an increase of 3 in the y direction. Join me in the next video where we'll continue looking at the gradient of a line, and particularly how the gradients of parallel and perpendicular lines are related to each other. See you next time.